Alkanes. Alkanes are hydrocarbon molecules that are joined by single covalent bonds. Pretty much these are the simplest hydrocarbons. And these are what we're going to look today at naming. Right? So these simple hydrocarbons that only contain single bonds between the carbons. And obviously you cannot form a double bond with the hydrogens because hydrogen has one valence electron, and so it can only bond once. Now, methane, simplest of all the alkanes, right? So it's carbon, right, which with its 4 valence electrons that can bond with 4 other hydrogens, right? And it's a main component of natural gas. Okay, so methane is the smallest alkane hydrocarbon that we can actually put together. Okay. Alkanes are aliphatic hydrocarbons, which are organic compounds in which carbon atoms form chains and non-aromatic rings. Okay. Now, 3 facts about these type of alkanes. Each carbon atom is bonded to the maximum possible number of atoms, either a carbon or to other hydrogen atoms. Chemists refer to alkanes as saturated hydrocarbons. Each molecule differs from the next molecule by the structural unit of CH2, and we'll see a few variations to that. A series of molecules like this in which each member increases by the same structural unit is called a homologous series. So the homologous series is pretty much, it's a continuation of all these links that usually occur in between, right, in between the CH3s, right? Remember how we said the CH3s usually are found to the outside of a chain, and usually in this middle part is where we'll have the CH2s, right? Because remember, carbon can bond, right, to 3 hydrogens, right? To look at a complete structural diagram, bonds to another carbon, which bonds to, let's say, this last carbon, okay, as such. Right? Notice here this middle carbon is already bonded, right, with 2 other carbons, which leaves it open for 2 more hydrogens, right? So as we said, this middle part, right, this is the homologous series that will pretty much, if we were to add more to this, would fit in between, and it would be this middle part that we would be able to extend. And we're going to see this in just a second when I show you guys an actual chart of the most common alkanes that we're actually going to name. And lastly, all alkanes have the general formula of CnH2n plus 2, right? So which means, here as we have in this formula, right, here we have this. So if we put in the place of n, right, Cn, just to kind of expand this, right? If let's say we have 4, our value, right, 4 carbons, right? So we're going to have C4, right, and H is going to be 2 times whatever our N value was, which was 4 carbons, that represented 4 carbons, plus 2. So 4 times 2 is 8, plus 2, 10. So the formula would come out to C4H10. And this is the pretty much the mathematical formulation that you can use for all alkanes. So if you're trying to name or trying to write a simplified formula, simplified molecular formula of a hydrocarbon, it's important to know the number of carbons, and it's important to be able to know that number of carbons that you're given and just substitute into the 2n plus 2 to find out how many possible hydrogens can I hold around all my carbons. Okay? With the example here that I use, what if we had an example like propane that I showed you guys earlier on, right, which contains 3 carbon atoms. So we put 3 into the value of n. 2 times n plus 2 is equal to 8. So the formula, if we had 3 carbons, we can fit a maximum of 8 hydrogens, and this is for the alkanes. Okay? So that formula only works with the alkanes. The name of these saturated hydrocarbons always ends in ane, right? So think of the word alkane. the A and E. So all of these saturated, right, only single bonds between the carbons, all end in A and E. Now, prefix is based on the number of carbons found in the longest continuous chain using Greek prefixes. Okay? Now, there is an exception to the rule, and that is for the first 4 hydrocarbons, okay, which actually don't. Right? But after that, we've got penta for 5, hexa for 6, we've got hepta for 7, octa for 8, nona, and deca. Right? So please do know that, and I'm going to show you guys a little hint as to how to remember the first 4, which are methane, ethane, propane, and butane. And now notice here, as we said, right, the smallest possible hydrocarbon, CH4. If we had another carbon, remember, so these would represent each end unit, right? Each end unit. And notice here, one end, second end, one end, second end. And let's go down to the bottom here, one end and the other end. And notice what's in the middle. All of them have this CH2, right? This CH2, which is that homologous series that I stated earlier on, right? So the CH2, so is a whole bunch of CH2s that are bonded in between your CH3s on the outer end for these saturated hydrocarbons. So, exception to the rule exists for the first 4 alkanes only. The following rule apply for the first alkanes. So, methane, ethane, propane, butane. Notice 1 carbon, 2 carbons, 3 carbons, 4 carbons. And in the 5, we use the Greek prefix, right? Penta. But for these ones, we use methane, ethane, propane, butane. How do you remember it? Really silly little expression called monkeys eat peeled bananas. Okay? So using this, we can remember, right? Using the M for methane, the E for eat, to remember ethane, propane, and butane. Right? So it's monkeys eat peeled bananas for the first 4 alkanes to help you remember it, because we're not using the Greek prefixes. Now, properties of alkanes. Alkanes are nonpolar, therefore have relatively low melting and boiling points. Okay? As the number of carbons in the chain increases, the boiling point will also increase. Right? So as you're getting more and more carbons bonded to it, as we get to the decanes, right, nonanes, you're looking at boiling point increasing. Okay. Now, naming straight chain alkanes, we just name them as is, right? Methane. So using this chart, you can just go about naming them. But not all of them are going to be as simple as just naming them in a straight chain. Sometimes we have to identify some of these so-called side chains. These are these branched hydrocarbons that exist, right? These branched groups that we'll find in a straight chain. And it's going to make a little more sense as we look at a couple of examples. Now, naming branched chain alkanes. So we can't just use the naming, right? We can't just use the naming. So we're going to have to follow the following 6 important rules. First one, really important. Identify the longest continuous carbon chain and name it, right? So you find out the row of carbons that are bonded to one another that will form the longest chain, right? The most number of carbons that we can link together in a straight line, and sometimes it branches off. And I'll show you an example. Now, what's important, after you figured that name out, right? That is your main, your main name for the your hydrocarbon, right? It's identifying all the other different branches that exist from that main chain. Now, next part that's important, identify the branches that come off the main carbon chain, right? So you want to find out, is it a methyl group? Is it an ethyl group? Is it a propyl group, right? So how many, what kind of smaller chains exist, right? And how many carbons exist with them? Now, the number of carbons in the main chain by placing the lowest possible number to the first branch. Right? So what you're going to want to do is you're going to want to number the different carbons. So 1, 2, 3, so if you've got 5 carbons in the straight chain, right, you want to number each one of the carbons. Right? and you always want to start your first branch on the lowest number. Okay. Identify which carbon the branch is located. Right. So once you've numbered your carbons, go about figuring out what group, because you need to identify that. Name the branch, and then the branch name comes before the main chain name. And it's going to make sense in just a second when we actually go through an actual example. So here's the example. Name the following compound. So what we want to do is we want to identify the longest chain. So we've got carbon, 1, 2, 3, 4 carbon chain, right? So we know a 4 carbon chain, and so that doesn't fit in the Greek prefixes, right? So we think monkeys eat peeled bananas. Okay, so we know the chain is a butane. Now, on the second carbon, right? So here's our chain. And here's our chain. On the second carbon, we have a 1 carbon branch. So a 1 carbon branch, we think of monkeys, right? Methane. So we've got a methane, but we're not going to write it down as a methane. We're going to write it down as a methyl. Right? Telling us what kind of a group. And actually, we can actually put that together. Let's combine it, right? Because there's nothing else really to tell us in here. The only other thing that we need is, where is this methyl group located? It is located, right? Because technically, if I don't say anything, I can put that methyl group anywhere. But if I put it on one of these, then it's no longer a butane group, right? So it's found on the second carbon, so we're going to write the number 2 with a hyphen. So the following compound is known as 2-methylbutane. This methyl group, there's a methyl group located on the second carbon of the main chain, which is butane. Okay, so what we have is pretty much the main chain, right? The branch that we have, and the location of the actual branch. Okay. Additional IUPAC rules for naming branched chain alkanes and other aliphatic compounds. If there are 2 or more of the same type of branch, give each branch a position number. Right? So we're going to give it pretty much a number. Also use multiplying prefixes such as di to represent if we have 2 branches of the same name, of the same group. Tri if we have 3, tetra if we have 4, however many we've got to tell us pretty much how many branches. So what's important is that we identify, let's first identify the main chain. So the main chain happens to be as follows. We've got 1, 2, 3, 4, 5 carbons. So we know we've got pentane, right? It's our main chain. Now, we have 3 branches from that. We've got 1, we've got another branch, and another branch. And they all happen to be a 1 carbon branch, right? So we know that they're all methyl, right? So it's a methyl pentane. Now, because we have 3 of them, we're going to use the prefix tri to tell us that we have 3 methyl groups that are associated with this pentane. Now, where are these methyl groups located, right? Because if I just give you that, where do we put these methyl groups? We can put them anywhere, right? And then that could end up throwing off our naming. But we have one of them here out of 2. We have another one out of 2. So we've got 1 out of 2. We've got another 1 out of 2. Because we want to state that there are 2 of them, and they're both located on the second carbon. We've got a third one, which is located here on the 4th carbon. And then we separate the numbers with a hyphen. So we've got methyl groups. We've got 3 methyl groups on our main pentane, but they're at the 2, and the 4 position. So the name of the following compound is 2,2,4 trimethyl pentane. Now, we're going to put commas between numbers and hyphens between numbers and letters. Really important to know, right? So that's how you know like when do I put a comma, when do I put a hyphen, commas after numbers. Okay? So commas, notice here, commas right after numbers. I've got a number with a letter, hyphen. And then the rest, well, we've got the trimethyl, right? There's 3 methyl groups on our pentane, which is our main chain. If there is more than one type of branch, name the branches in alphabetical order. Determine the alphabetical order by using the first letter of the root, so methyl or ethyl, not by multiplying the prefixes, okay, di and tri. So we're basing it from the groups, right? So if I have an ethyl group and a methyl group, I'm going to list the ethyl group first, followed by that. So we're not going to use the di-tri. So let's say I had a dimethyl, right? And then a trimethyl, right? As an example. This is just a hypothetical. Because the D comes before T, that doesn't matter. It's based on the actual group. Did I put both methyl? Sorry, ethyl. Okay? So we're basing it on the carbon name, the number of carbons. Okay, so let's look at the following. So here we have carbon. So what we can do here is we want to look at the chain. So I can name this chain as follows. Here's the chain. Right? Or if I want, right, we've got 5 carbon chain. This carbon, I can actually name it or label it as such. So here I can have that chain. Because in reality, even this way. So let's leave it this way. We've got 5 carbons. So we know this is part of the pentane, right? We've got, here now let's number the carbons. We've got 1, 2, 3, 4, 5 carbons. We know we have a methyl group. We've got 2 methyl groups. We've got 2 methyl groups. And so, because we've got 2 methyl groups, it's a dimethyl. Where are they located? At the 2 and the 2. Then, we also have now this other branch, which is a 2-carbon branch. And because it's a 2-carbon branch, we have an ethyl group. Right? So the E comes before M. So we're going to list that first. But where is this ethyl group located? It's located on the 3rd carbon. Right? So when we name this, it's going to be a 3-ethyl. Now we want to list the next part, the next group. So now letters to numbers, it's a hyphen, 2, 2, dimethyl. Right? So dimethyl, and what was the long side chain? Pentane. Okay? So we have a 3-ethyl, 2,2-dimethyl pentane. So notice we've got the 3-ethyl, which means we're on the 3rd carbon of our pentane chain, right? We've got on the number 2, on both sides, I guess, of the carbon, right? We've got 2 methyl groups that are found on that pentane chain. Okay. Now, if more than one chain could be the main chain because they're the same length, choose the chain that has the most branches attached to it. So, we can go in pretty much any order and use that same one. But what we're actually going to do is we are actually going to use the following chain here. So again, we're in the pentane group. So we've got 1 carbon, 2 carbons, 3 carbons, 4 carbons, and 5 carbons. So we know we are part of the pentane chain. So now, we've got a methyl group, and we've got another methyl group. So where are they located? They're located on the 2 and the 4 So 2 in the 4, and we've got 2 methyl groups, so it's a dimethyl. Right? And we also have the following. We've got an ethyl group, which is located on the 3, so we've got a 3 ethyl group. So we know it's going to end in pentane. So which one of these are we going to write first? Well, again, as we said, we put it in alphabetical order based on the branch. So this one will be as follows. It will be named 3-ethyl hyphen, and now 2,4, and because there are 2 of them, we have a dimethyl pentane. Okay? And there it is. Okay, so notice what the numbers, these numbers again, right, they represent where do these groups, okay? So there's an ethyl on the number 3 carbon. There are 2 methyls, 1 on the 4 and 1 on the number 2 carbon of our main chain, which is the pentane. So let's name the following compounds. Take a moment and identify the following compound. So let's try to find the longest chain. And easily we can say, well, you know what? Let's do the chain all the way there, right? Straight line. Don't be fooled by that because we've got 1, 2, 3, 4, 5 carbons. But if we decide not to include this, right? Remember, we originally had 5. But now if we look at it this way, we've got 1, 2, 3, 4, 5, 6 carbons. Okay, so that will make it the longer chain. So remember, when we're naming them, we're always naming it based on the longest chain. So we know we've got 6 carbons, so we know the chain is a hexane. Right? Notice the A-N-E ending. So let's look for other branches. Well, we've got one branch, right, a methyl group on the number 2. We've got another methyl group, but now this one's on the 4. So we have on the 2, we have on the 4 carbon, right? We've got methyl, right? They're part of it's a methyl group, but we have 1, 2 methyl groups, so we label it as dimethylhexane. So 2,4 dimethylhexane. Let's take a moment and look at this one and try to identify the longest chain. And then go about naming the following compound. Okay, the longest chain would be as such. Okay, so now we can go about naming it from this carbon right here. But because the smaller, the closest group, next carbon group, is there, we're going to number it as such. 1, 2, 3, 4, 5, 6, 7. So we know we've got 7 carbons, which represents heptane. We've got 1 methyl group, we've got another methyl group, right? So we've got 2 methyl groups, one at the 2, the other one at the 5. So we've got a 2 and a 5, and because there are 2 methyls, right? These are methyl groups. We put dimethyl, right? Because there are 2 of them. We also have the following. We've got these 2 carbons, which represent an ethyl group. And this ethyl group is found on the number 3 carbon. So it's a 3-ethyl, right? So now, we know it ends in heptane. Which one of these 2 are we going to put first? If you said the one that's in alphabetical order, you'd be correct. So we're going to put the 3-ethyl, then we're going to follow it by the 2,5 dimethylheptane. So it's going to look as follows. A 3-ethyl hyphen 2,5-dimethyl heptane. Okay, let's look at the next sample problem. We're going to name the following, and this one might not be as easy to have identified the main chain, right? Because there's a number that we can look at, right? And if you look closely, this is what you should get as your main chain, right? Because here we will have one carbon, and again we name it closest to the first branch chain, right? So 1 carbon, 2 carbons, 3 carbons, 4, 5, 6, 7, 8 carbons that we can actually find that for our main chain. So we have octane. All right. Next, we want to look at our first group. So our first group here, we've got a branch group. We've got 1 methyl there. We've got another methyl there, and we've got another methyl there. So we've got a tri-methyl groups, right? So 3 methyl groups. Where are they located? 2 of them are located at 2, right? So we draw them, we write down the number 2 carbon, the number 2 carbon, and the number 4 carbon, right? Hyphen. The other group that we have, the other branch group, are 3 carbons, right? So we have monkeys eat peels, right? So we've got what we call a propyl group. Propyl group, where is it located? It's located on the 4th carbon, right? So here, 4th carbon has this propyl group. So which one of these do we write down first? Well, we've got P and we've got the letter M. So whichever one comes alphabetically is what we write first. So we are going to list it as 2,2,4 hyphen trimethyl hyphen 4 propyl octane, and there is our name. So it's 4 trimethyl 4 propyl octane. So as we said, just to identify the numbers, we've got 3 methyls located on the number 2, the number 2, and the number 4 carbon of our octane. We've got a propyl group that is found on the 4th carbon of octane. So note that all these numbers are associated by the main chain, and whichever one we're numbering. And we always want to put it with the lowest number. We never want to name it as 4,2,2 trimethyl. Right, we always put it in order that the numbers appear, and then these other branch groups, we always put them in alphabetical order as well, but not based on the diatribe. It's based on their actual, the 1, 2, 3 carbons, whatever they are.